Yes, my good morning, students. Today is in your fundamentals of computers. We are going to see the laws of Boolean algebra. Okay. In the previous videos and all, you have seen the Boolean algebra, what is Boolean algebra, or how to form a for each and every expressions, how to form the gates, what are the different logical gates, everything. And now today, what it is now after that we are going to see what are the different laws of Boolean algebra. So before that, what is the need of this law? So if you can able to understand these laws, we can able to easily simplify an expression. In the previous video, I have said how to develop a draw a gate or draw a logical design for a given expression, right? So like this we were doing it. Do you remember? Like this, if an expression is given, how to draw things using a gates, different gates and all, we were discussed like that only. So what is the need of this one? If I have this loss, I can able to simplify the expression. By simplifying the expression, if an expression is given, I can able to, using those laws, I can able to simplify. And if I simplify, the gates can be reduced. The gates which I am using, different gates which I am using it, can be reduced, and I can able to use this to reduce the gates, gate design. To design the gates, I can able to reduce the gate by simplifying the expression. To simplify my expression, I need to learn certain laws. So that's what we are going to see today. So what is the use of these laws? We can able to use these laws to simplify the given expression, through which I can able to reduce the gates which I am using it. So one by one thing we'll see. The first one is called as the first law is called as an annulment law. Annulment law. In this, what will happen? In your annulment law, we have each and if I have a dot, it is called your AND gate and OR gate. And OR only we are going to see a combinations. Here, what is this annulment law is, if a variable is AND with a 0, it is 0, okay? If your variable is odd with 1, it is 1. So this is a law. How to prove this one? So for the proof, what you have to do? So right, these are the two laws. To prove, very simple. You have to give a two inputs and see whether the thing is. So how to prove that one? So first here let me solve for this one. If my a is equal to 0, under this situation, if my a is equal to 0, if I AND with this one, what I am getting it? 0 dot 0 is equal to, with the AND 0 with the truth table with the AND you have to see. So 0 with 0, you are getting 1. So if a is equal to 1, if my input is 1, what is happening? So 1 dot 0 is also 0. So through this I can come to a conclusion that a variable AND with a 0 is equal to 0. And the other one here how to prove this one? So here for the proof is like this. If a is equal to 1 under these circumstances, if my input is 1 and it is odd with 1, it will be 1 again. Same thing. If my a is equal to 0, 0 plus 1 is equal to any one is equal to positive. So that is what is the proof of this one. So this is your first law called as annulment law. If a variable is AND with 0, I am getting 0. If the variable is odd with 1, I am getting 1. This is called as annulment law. So these two laws you learn it, and proof is given here. Proof you can make it in this way. So next come to the identity law. Identity law, here a variable is AND with 1. Under this situation, I'll get the same a again. Identity, same it will be. So that's the name identity law. If the variable is odd with 0, I'll get the a again. Same like this we can able to prove it. So what is the proof? How to prove it? How to prove it? If the same situation, if a is equal to 0, just give an input 0 and 1 to that variable and prove this one, because it is a Boolean algebra. The variables can able to hold only zeros and ones. So a given variable, put a 0 and see. The same variable, put 1 and see. If you are getting this one, it has been proved. So what it is? If it is 0 dot 1 is equal to what I am getting? 0. Okay, if I am taking my a is equal to 1, under this circumstance, a dot 1 is equal to what I am getting? 1. So what answer I am getting? Whatever it is, I am getting the a answer which I got it. So that is a proof of this identity law. Come to the or part. If a is equal to 0 and situation is a plus 0, what I am getting? 1, which is nothing but your a again. Sorry, I made it a 0 here. Nama? So 0. So 0 plus 0 is equal to 0, which is nothing but your a. Next, if a is equal to 1, Under the situation a plus 0 is equal to 1, which is nothing but my a again. So whatever I do, if I or with my 0, I'm getting the same a, which is called as an identity. If I am and with my 1, I'm getting an a again, which is the same a again. So it is an identity law. So this is the identity. Why the name identity? Because the same one I'm getting. So identity, same it is. So this is 1, 2 laws. So we have seen in annulment law, we have seen 1, 2 with your and or, identity with your and or. So all the combination with and or you have to learn like this. Okay, proof you have to do it in this way. Come, the next one is called as an idempotent law. Idempotent law, it is very simple. A variable itself, a variable is and with itself, we'll get the same answer. If a variable is odd with itself, we'll again get the same a again. Very simple, same thing. How to prove it? So prove each and every time, same thing, 2, 3 times, 4, 5 laws I'll prove. Remaining proofs you have to do it. Okay, let me prove it. If a is equal to, what can I give? I can able to give only zeros and ones because it is a boolean one. A input can have either 0 or 1. So if I'm having 0, what I'll do? 0 and 0 is equal to 0 again. If a is equal to 1, so 1 dot 1 is equal to 1. You're getting the same answer, right? So this is called as idempotent. So idempotent is nothing but and or odd by itself. So remember this word, by itself. Doing the things by itself, I'll get the same thing. The same thing here. Let me see for your OR operation. If my a is equal to 0, 0 plus 0 is equal to 0, right? Same thing. If a is equal to 1, 1 plus 1 is equal to 1. I'm getting the same one, right? So this is called as idempotent law, right? Next, coming to your complementary law. Complementary law, what it is? Complement means a variable and it's not in reverse, inverse, sorry, not reverse, inverse of that variable. A variable and the inverse of the same variable will be 0. If it is an AND operation, a variable or with a inverse of that variable will be 1. So what it is? Inverse means this a or a dash. We will tell inverse not get. That's what. So if I am taking my a equal to 0, suppose my input is a equal to 0. Let me prove that one. So what I am taken? This is my 0. And the inverse of 0, 0 means 1, 1 means 0. So what it is? 0 dot a dash. Because it is 0, it will be 1. What is an answer? 0. So this is the proof of this particular thing. Right. Come. If I am taking my a is equal to 1, both the inputs you have to check. If my a is having 0, this is my scenario. Next, if my a is equal to 1, 1, reverse of 1 is 0, which is also 0. So a variable and its reverse is and with it, then it is 0. So this is your complementary law. Next, coming to your if here with your OR operations. If a is equal to 0, so 0 plus and its reverse. 0's reverse is 1. 0 plus 1 is equal to 1. Same thing. If a is equal to 1, if I am taking 1 and its reverse will be 1. So this is what. So a complementary law is a variable and with its reverse will be 0. If it is and, it will be 0. If a variable is odd with its reverse, it will be 1. This is called as complementary law. Okay, this is your laws right now we have seen. These all these variables, and one more is the last one is your double negotiation. This one also learn. Double negotiation. A variable is negotiated with 2 times, we'll get the same variable a. That is very easy. What it is, if only one single variable, it's negotiated 2 times. Dash as well as dash. Means if a is equal to 0. Okay. So if I'm doing 1 time negotiation, a inverse, it is equal to 0 will become 1. So with this answer a dash, this a dash again it is become what it is, double dash will become 0, which is nothing but your a. So if I am taking a equal to 0, double negotiation, first time negotiation it will be 1, and this again negotiated will get your 0, which is nothing but your a. Next, suppose if I am taking a is equal to 1, so first time 1 dash will become 0. This answer again should be negotiation, will I get 1. So this is nothing but your a. So double negotiation is also these things. So these are the 5 different laws with a single variable. This also you remember. All this where what I have seen you have done with your single variable. So after this we are going to see with your double variable. So these are your single variable laws. So remember, annulment law, identity law, idempotent law, complementary law, and double negotiation law. These are all your, what it is, these are all your single variable. Using a single variable with your and or operations, we have done the laws. So learn this one. This is how we have to do it with a single variable. So next what I'm going to see is your, okay, three different, the remaining laws are all, you will be having a combination of 2 or 3 variables, like your associative law, then you have a commutative law, then you have a distributive law, and one more you have your absorption law and de Morgan's law. These are the different remaining 5 laws using your more than one variables. So right, so first let me discuss your commutative law. So till your this 5, so divide your laws as a 10 single variables. For a single variables, let me repeat again, you have an annulment law, identity law, idempotent law, complementary law, and double negotiation law. These and all comes under single variable. Now next we are going to see 2 or more variables. For those laws again 5 is there. In that way you learn it. The laws to be learned can be easily learned. So come to your first commutative law. Commutative law is nothing but, like in your normal algebra you would have studied. I think so. Okay, let it be. Commutative law is with and or operations. Both I am going to see. So A dot B is equal to B dot A. Okay. So this are dot operations. How to do it? How to prove this one? So I am teaching this proof. For 2 laws I will teach it. For the remaining things you have to prove it and submit me the answer. Let me prove this one. So this proof can be done using a truth table. So I have 2 variables. So I have to make a, see for this one, let me draw a truth table. A and B with your A dot B. So this is my input and this is my output for this one, for my left hand side. So what can be the combination? It can be 0, 0, 0, 1, 1, 0, 1, 1. 2 variables, 2 to the power of 4. So 4 combinations you'll get. This and all again. No need to teach. It is very clear that why only 4 combination, 2 to the, because 2 variables, 2 to the power of 2, 4 combinations you'll get it. So obviously you know the answer. What is the answer for this one? 0, because it is an AND operation. 0, 0, 0. When both are 1, it will getting this one. This is A dot B. Okay, this is for our LHS. For LHS, left hand side. So then come for your RHS proof. RHS, how to prove it? Same thing, A, B, but B dot A, whatever it is, what you will get it, same answer you will get. So this is how you can prove that law, that it is same. So your LHS is equal to RHS. Through this I can able to prove this commutative law. Okay, the proof is clear. Right, this is for your AND operation. The same thing you are going to see for your OR operations. A plus B is equal to B plus A. So how to prove that? For your LHS, truth table for your A, B, A plus B. This is your input, this is your output. So if it is 0, 0, 0, 1, 1, 0, 1, 1. What can be the answer? 0, 1, 1, 1. Right? So come to here. For your RHS, I will be having A, B. This is your B plus A. Whatever it is. 0, 0, 0, 1, 1, 0, 1, 1. So what can be the answer? B plus also. B plus A also. 0, 1, 1, 1. So your LHS is equal to RHS. So this is how you have to prove it this one. The LHS is equal to RHS. Okay, this is your commutative law. Commutative law with your and or. A dot B is equal to B dot A. A plus B is equal to B plus A. So this is your commutative law. Okay. So the next law, let us see. The next law is your associative law. Okay. For your associative law, again you have your and also and or also. In your associative law, what it is? A dot B bracket. A dot B dot C is equal to A dot B dot C. Bracket wise also it varies. Right. So this is your associative. Normal, in the normal algebra what you have done. But here it is a Boolean algebra. Boolean algebra means, don't forget, the variables will have 0 and 1 combination. Only that much that much difference is there. So with the AND. So I'll prove this one. The other associative law for the OR you have to prove me and submit the answer. So now I'm going to prove only for your AND. So how to do it? So let me first take your LHS, left hand side. How many variables are there? 3 variables are there. So always the input will be A, B and C. So how many possibilities I'll get? 2 to the power of 3, 8 combinations I'll be getting. So what I'm going to do it here, first the bracket I'll finish it off, A dot B, and then I'll go for the C. Right, first let me write the combinations of this one ABC. So it is 0 0 0 0 0 1 0 1 0. This already know, I have taught you how to write this one in the last but before videos and all I taught you. So you have to write it down, all the 8 combinations you have to make it. 8 you are getting 1 2 3 4 5 6 7 8. So 8 inputs is being given because 3 variables, all the 8 inputs combinations first you make it. In this LHS, first bracket you have to complete. So A dot B you have to do it. Okay, A dot B, first output. Then go for your A dot B dot C. So only concentrate on your, just remove this one, only concentrate on A dot B and give the answer. So A dot B, what it is? 0 dot 0. A dot means any, if both the variables are same, you will get a 1 over there. So if you see here, I'll be getting a 0 here because 0 dot 0, 0 dot 0, 0 dot 1, 0 dot 1, 1 dot 0, 1 dot. Till this I'll be getting 0. You know that using your AND operation. So here also 0, 0, 0, 0, 0, 0. Till this. Don't see your C, only see your A and B's combinations. Next what I'm getting? A, B. 1, 1 I'm getting, so it will be 1. And again 1, 1 I'm getting, so I'm getting 1. I can able to follow, right? Here I'm getting 1, 1. You only see your A, B combinations, write it down. So I am getting 1 and 1 over there because my A, B is 1 and 1. Right, ma? Followed. Right. This is over. So A, B is over. Next I have to make a next combination of A dot B is over with a dot C. So this is my A dot B. So with this, forget this one. Forget this part. Only with the C you have to make a combination. With the C you have to see these both things. So A dot B dot C, 0 0 0. Where and all your same variables are there, there you have to make a 1 over there. So what I'll getting it? See, again I'm telling you, look into only your this output and the C part. Only the output and the C part. So what I'm getting? 0 0 0 0 0 0 0. Here 1. At the end part I'll be getting 1 because both are 1 1. So this is only for the LHS. Okay, proving your LHS. So now come to your RHS. Okay, so LHS is over. Inside your RHS. So here what is the same thing? You have to make an input of A, B, C with all the combinations. Sorry, 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. All the 8 combinations of your ABC for RHS. Next, first what I have to take? I have to take BC now because that is my bracket inside that bracket. So make a combination of BC first. B dot C. So B dot C, again same thing. Forget your A. Only you see where and all you're having combination of similar ones. So if you see here last I'm getting 1 1 and here 1 1 I'm getting. So only in those places I will be getting 1. So look into 0 dot 0 0, 0 dot 1 1, 1 dot 0, sorry 0 dot 1 0, 1 dot 0 0, 1 1. So 1 over there. 0 0 0, 0 1 1, 1 0, sorry 0 1 0 0, then 1 1 1. Only where the similar things are there you will be getting 1 over there. So these two places 1 remaining and all 0 for your BC. So after this one I have to AND with your A. So what is the next one? I am having A dot B dot C, right? So I already have for B dot C I have a output here. C with your A. So forget these two. Forget your B and C. Only with your A you make a combinations. So 0 0 0 0 0 0 0 1 and 1 over there. Okay, so what I'll be getting? Are you getting that? So everywhere 0, only here I'm getting your 1 as well as 1 here. So automatically what will happen? 0 0 0 0 0 0 0 and 1. So this is I'm getting. So see your LHS and your RHS, both the truth tables are same. So this is how I am going to prove my associative law, that your LHS is equal to RHS. A dot B dot C is equal to A dot B dot C using your truth table. This is for your AND operation I have done it. Like this you have to prove for your or operation and submit me. I am not going to do it. That is your exercise. You have to do it. Try to do it. Okay, so this is your associative law. Today's it is okay. For the today's class, I have taught only 2 laws for your with the double variables. Learn the remaining laws and write it down once and show and submit it to me. Write all these laws, all the 5 laws, 5, 6, 7. Okay, the 7 laws. Okay, in the tomorrow's video, I'll teach you about your distributive law, absorption and De Morgan's law. These 3 laws I'll teach you in the tomorrow's class. So today learn this one, work it out, and for this or solve it, write all the laws once and submit it to me. Thank you.